Electrochemical machining operations are performed with tungsten as the tool and copper and aluminium as two different workpiece materials. Properties of copper and aluminium are given in the table below. Ignore overpotentials and assume that current efficiency is 100% for both the workpiece materials. Under the identical conditions, if the material removal rate of copper is 100 milligrams per second, the material removal rate of aluminium will be. So we need to find out the material removal rate of aluminium in also milligrams per second. Let's look at the solution. As far as electrochemical machining is concerned, the material removal rate is given as MRR is equal to AI by FV, where A is the atomic mass, I is the current, V is the valency, and F is the Faraday's constant, which is 96,500 Coulomb. Given in the question that copper has a material removal rate of 100 milligrams per second. Using the above equation of material removal rate in electrochemical machining, we get 100 is equal to 63, which is the atomic mass of copper as per the given table, into I by 96,500 into valency of copper, which is equal to 2 as per the given table. Let us consider this as equation number 1. Similarly, if we write the equation for material removal rate in aluminium, we get 27 into I by 96,500 into 3, where 27 is the atomic mass of aluminium and 3 is the valency of aluminium as per the given table. Let us take this as equation number 2. Now, dividing equation number 1 and equation number 2, the only unknown is material removal rate for aluminium, and that turns out to be 28.57 milligrams per second. The correct answer range given for this question is 27 to 30.